Hello and welcome, retro computing enthusiasts and technical aficionados, to another episode of the Computer Vault podcast, the podcast where we discuss the history of computers, computing, and IT, and where we uncover the amazing stories that shaped our modern digital world. I'm Aidan, and in this episode, we'll explore the historical significance, innovative design, and technical details of the Amstrad PCW10. Whether you're an engineer who appreciates the nitty gritty details of hardware architecture, or a nostalgic fan who remembers the excitement of word processing on an all in one machine, our discussion today is tailored just for you. Throughout our conversation, we will cover aspects such as its CPM functionality, integrated word processing capabilities, and printer integration. We'll also compare it directly to contemporary systems like the IBM PC series and other CPM based business computers, and even delve into the evolution of word processor software in the mid 1980s. So, buckle up as we press start on this technical time machine. The Amstrad PCW10 represents a fascinating amalgamation of purpose-built design and user-friendly computing, tailored primarily for the business and educational markets. At its heart lies the ubiquitous Zilog Z80 microprocessor, which was a mainstay in many CPM systems during the early 1980s. Clocked at approximately 4 MHz, this CPU provided a robust foundation balancing efficiency and performance for the word processing tasks it was designed to handle. Memory management in the PCW10 was straightforward yet effective. The system was equipped with 64 kilobytes of RAM, which at the time was considered quite adequate for running CPM 2.2, the operating system which underpinned the PCW10 software environment. The integration of CPM not only streamlined application development, but also ensured compatibility with a wide range of native business applications. Storage in the PCW10 was facilitated via built-in floppy disk drives, which were provided in a 3-inch format. This was a strategic choice by Amstrad, as the use of proprietary disk formats was intended to secure an ecosystem of software that works seamlessly with their hardware. In terms of display, the PCW10 featured a monochrome green-on-black CRT that mirrored many of the design aesthetics of early computing terminals, but was optimized for the simpler graphics and text output needed for word processing. One of the most celebrated aspects of the PCW10 was its integrated word processor, a tool that was, at the time, both elegantly simple and technologically advanced. The PCW word processor was custom designed to offer a highly efficient editing experience. Its layout, characterized by a full travel keyboard reminiscent of a typewriter, combined with dedicated function keys for rapid formatting and editing, made document creation feel like a natural extension of a writer's creative process. In many ways, it was a precursor to the modern word processors that we now take for granted. Printer integration was another hallmark of the design. Amstrad's holistic approach meant that the PCW10 was engineered with a bespoke printer interface, eschewing the need for multiple ports and adapters. This integration was not simply technical convenience, it was a deliberate attempt to create a streamlined user experience. The printer, almost an extension of the computer itself, supported a variety of fonts and formatting options, though its output was, of course, constrained by the technical limitations of the mid-1980s. To summarize some of the core technical specifications, microprocessor was a Zilog Z80 running at approximately 4 MHz, memory 64 kilobytes of RAM with CPM 2.2, storage were proprietary 3-inch floppy drives, display a monochrome CRT display optimized for text mode, word processing, custom integrated word processor with advanced formatting tools, and printer integration, dedicated printer interface for seamless document printing. In the next segment, we're going to compare these specifications and functionalities to other systems available at the time, but first, let's step back to understand the historical context of the PCW10. The mid 1980s were a dynamic period for personal computing. On one hand, business users demanded more sophisticated document processing capabilities. On the other, home computing was beginning to capture the public's imagination. Amstrad, an innovative company from the United Kingdom, struck a balance by developing a series of computers that were both accessible and purpose built for tasks like word processing and educational computing. The PCW 10 was a logical evolution in this lineup. The development of the PCW 10 was spearheaded by a dedicated team of engineers who sought to innovate beyond the limitations of existing CPM based systems. In an era where many platforms attempted to simply repurpose typewriter technology into digital form, Amstrad opted for a design that addressed both hardware integration and software usability in a novel way. Interviews with several developers from back in the day reveal that one of their primary challenges was balancing cost with the need to create a system that was purpose built for text editing without overwhelming the user with unnecessary functions. According to archival magazine reviews from publications such as Practical Computing and Your Computer, the PCW10 was widely praised not only for its affordable pricing, but also for its refined user interface. Service manuals from the period indicate that Amstrad's design philosophy was firmly rooted in simplicity and efficiency. This was particularly evident in the machine's electronics. By dedicating resources to well integrated peripherals such as printers and keyboards, Amstrad ensured that users experienced minimal friction during day to day operations. Another fascinating aspect of its development was the decision to heavily invest in CPM compatibility. CPM was, at the time, the operating system of choice for many business applications, and Amstrad recognized that by aligning with it, they could tap into an existing library of productivity software. However, that they also innovated by tailoring the operating system experience to the needs of word processing. For instance, while standard CPM systems offered command line interfaces that could be intimidating for everyday users, the PCW10's firmware included a more guided, application centric approach. This hybrid approach made it easier for both legacy users who appreciated CPM's flexibility and newcomers who are transitioning from mechanical typewriters. It's also critical to appreciate that the PCW10, along with its sibling models in the PCW line, played a role in democratizing computer usage in Europe. By reducing the system's complexity and integrating functionalities that were once scattered across multiple devices, Amstrad made it possible for small businesses and educational institutions to own and operate a computer that was ready for everyday tasks right out of the box. Moreover, behind the scenes, there are spirited debates among hardware designers in Amstrad's research and development department over whether to include more advanced graphics capabilities or to focus on optimizing text processing. Ultimately, the decision was made to prioritize reliability and ease of use. While the outcome might have rendered the machine less versatile in terms of multimedia, it remains a prime example of design trade-offs in early computer engineering, where sometimes specialization was the key to widespread adoption. To fully appreciate the PCW10 and its lasting impact, it's worthwhile to compare it with some of its contemporary counterparts. During the mid 1980s, the computing landscape was populated by a variety of systems that often juggled between general purpose business computing and home computer entertainment. Let's examine how the PCW10 stacks up against some of these platforms. First, consider the IBM PC and its derivatives that were rapidly gaining popularity in the business world in the United States. The IBM PC, equipped with Intel's 8088 processor and a more extensive hardware ecosystem, was a powerhouse intended for multitasking and more expansive applications. However, in contrast to the PCW10, the IBM PC was far from an integrated solution for word processing. Its ecosystem required additional peripherals and software packages that did not come pre-tuned for a seamless experience. While the IBM platform eventually led to an explosion in general purpose computing, for many business users and educational institutions in Europe, the simplicity of the PCW10's integrated approach was far more appealing. Likewise, another strong competitor in the CPM arena was the Osborne 1. Osborne was renowned for its portable design, a precursor to our modern laptop, but it was engineered primarily for businesses travel. The PCW10, conversely, focused on stationary performance with a much more robust word processing program and an integrated printer interface that made it ideal for office environments. The Osborne One's display and keyboard, while quite effective for its time, simply couldn't compete with the thoughtful ergonomics of the PCW10's full travel keyboard and user friendly layout. Even within the landscape of dedicated word processors, the PCW10 carved out its own niche. Competing word processing packages like WordStar and early versions of Microsoft Word ran on multi-platform systems, but they often required additional computing resources and complex configurations to match what the PCW10 delivered as an out-of-the-box experience. This specialized functionality made the Amstrad machine a go-to solution for writers and administrators who needed a reliable, ready-to-use system for text-intensive tasks. As our discussion turns to the performance specifics, it's interesting to note that many of the technical decisions in the PCW10 were deliberate compromises. For instance, while the use of a relatively slow 4 MHz Z80 chip may seem underwhelming by today's standards, it was a perfectly balanced choice when paired with a streamlined operating system and dedicated word processing software. Whereas the IBM PC's 8088 processor offered more raw computing power, much of that power was allocated to supporting multitasking and graphical operations, which the PCW10 simply did not aim to provide. Additionally, the integration of the printer in the PCW10 simplified the overall system architecture, reducing both complexity and cost. In many competing systems, users were forced to buy separate printer packages, and interfacing them with a computer required significant technical know-how. The PCW10's design philosophy was to eliminate these barriers, thereby establishing a new level of user convenience that was frequently cited in contemporary magazine reviews. The amplitude of CPM's influence is evident here as well. CPM 2.2 provided an intuitive file management system, a stable command line for those who wished for greater control, and compatibility with a host of third-party applications. However, it is the way in which Amstrad streamlined this operating system for the PCW line that sets the PCW10 apart from other CPM machines. Where many systems offered raw computing interfaces requiring significant setup time, the PCW10 was designed to be almost self-configuring, guiding the user through its functionalities with minimal friction. Let's not forget how the PCW10's design ethos extended into its physical construction. Contemporary machines such as the Sinclair QL and even certain IBM PC-compatible systems were often criticized for their clunky cases and utilitarian designs. In contrast, the PCW10's design was sleek and purpose-driven. Its integrated aesthetics meant that every component, from the keyboard to the built-in printing mechanism, was engineered to work in unison, reflecting Amstrad's overall commitment to a cohesive user experience. Moving into the deeper technical layers of the Amstrad PCW10, we encounter several design decisions that not only influenced its performance, but also shaped many hardware practices in subsequent decades. The Zilog Z80 processor, renowned for its elegant instruction set and efficient handling of I/O operations, was a central element of the machine's operational philosophy. Its simplicity allowed developers to write compact code that maximized the limited 64 kilobytes of memory available. The CPM operating system formed the software backbone of the system. By utilizing CPM 2.2, Amstrad ensured that users had access to a wide range of available applications, from file management utilities to rudimentary graphics programs. However, the machine's architects went beyond simply adopting CPM. They modified peripheral system routines to optimize performance for word processing. For example, the disk I/O routines were tweaked to minimize load times for the word processor, an adaptation that is well documented in service manuals of the day. Printer integration deserves particular attention. Unlike many computers of the era which relied on third-party printer drivers or externally mounted ports, the PCW10 featured a dedicated printer interface built directly into the system board. This meant that the communication protocols between the CPU and the printer were tightly interwoven with the core software. In practice, this tight integration reduced latency in printing documents and allowed for more precise control over printing parameters such as font selection and page layout. Detailed technical reviews in periodicals like Practical Computing lauded this approach as it simplified maintenance and troubleshooting. Interviews with former Amstrad engineers have revealed that a significant portion of development time was invested in fine-tuning these connections to strike an optimal balance between speed and reliability. The word processor itself was a marvel of integrated software design, developed in close collaboration with professional writers and typographers. The software featured a user interface that was simultaneously elegant and utilitarian. The layout combined aspects of traditional typewriter ergonomics, complete with tactile key feedback, with a digital environment that permitted rapid document editing and formatting. Direct calls to the underlying CPM file management system allowed for swift document saving and retrieval, reducing the friction often experienced on systems where word processing software was an afterthought. From a firmware perspective, the PCW10's boot routines and system diagnostics were designed to be intuitive and accessible. Users could access a built-in self-test mode, which was particularly useful in an era when computer downtime could significantly disrupt office workers. This self-test mode was a precursor to modern diagnostic software, and it provided detailed error codes that technicians used when servicing the machine. The level of detail provided in these diagnostics, combined with the clarity of the service manuals, meant that even technical novices could receive guidance on troubleshooting hardware issues. Delving deeper, the memory architecture of the PCW10 was notably straightforward, yet required clever programming practices to overcome the constraints of a 64 kilobyte address space. Techniques such as bank switching were rarely necessary given the computer's specialized application, yet developers were mindful of the potential growth in software complexity. As a result, many of the applications were written in highly optimized assembly code, an art form in its own right at that time that took full advantage of the Z80's cyclical capabilities. In terms of connectivity, while the PCW10 did not include networking capabilities in the modern sense, its design did accommodate a certain level of peripheral integration. Serial and parallel ports, though limited, allow for the connection of additional devices such as external modems and storage units. These ports were critical for users who needed to transfer files between systems or integrate the PCW10 into larger business environments. The flexibility offered by these connectors was highlighted during developer interviews archived in retro computing magazines, where it was noted that a small community of enthusiasts even managed to retrofit modern interfaces onto the system, bridging the gap between vintage hardware and contemporary technology. At its core, the Amstrad PCW10 was designed to be a word processing powerhouse in a pre-WIMP Windows icon menus pointer era. The dedicated word processor software delivered a level of clarity and efficiency that was detailed in numerous magazine reviews at the time, built to facilitate rapid text entry and document formatting. The interface combined the familiarity of a typewriter with innovative digital shortcuts. Unlike general-purpose computing platforms that offered word processors as one of many applications, the PCW10's word processing software was architected as a seamless extension of the operating system. The result was an intuitive user experience where commands to manipulate text, adjust formatting, and print documents were deeply rooted in the hardware capabilities. This integration allowed for sophisticated features such as margin control, column settings, and even rudimentary spell check functions long before these became standard on personal computers. Despite its limitations by today's standards, the PCW10's word processing features were anticipated by the demands of small offices and independent professionals. Many users noticed that the clarity and consistency of printed documents were superior to many competitor systems, thanks in part to the integrated printer interface. Dedicated keys provided rapid access to common formatting commands, and real-time feedback on text layout allowed users to produce professional-looking documents without having to navigate complex menus. It is particularly noteworthy how the PCW10's word processor drew design inspiration from established programs like WordStar, yet it refined the user interaction model. The integration wasn't just about functionality, it was about creating a user experience that felt natural. With well-documented routines available within service manuals and insights gleaned from developer interviews, it's apparent that substantial effort went into minimizing keystroke overhead. This approach contributed significantly to the eventual popularity of the PCW10 among sectors that prize speed and clarity in document preparation. When we compare the PCW10 to other business computers of the 1980s, several points of divergence become clear. Early systems such as the IBM PC and even the Apple II series were designed to cover a broad set of applications. Their versatility was undeniable, but this breadth also came at a cost of user friendliness in specific tasks, word processing being one of them. The IBM PCs, for example, often required additional components and software suites to achieve the same level of performance in document creation that the PCW10 offered out of the box, but not only necessitated a higher initial investment, but also demanded technical expertise to integrate disparate hardware components. In contrast, the PCW10's integrated design dramatically reduced the complexity of system setup and maintenance. Likewise, other CPM machines, while reliable for business applications, frequently sacrifice ergonomic considerations. The design of the keyboard, the responsiveness of the system to rapid input, and the real-time display updates in the PCW10 were lauded as forward-thinking improvements. Detailed comparisons in magazines often positioned the PCW10 as a specialist tool that excelled at one task, word processing, whilst its competitors tried to be all things to all users. One of the most interesting debates amongst retro computing circles is whether the PCW10's focused approach ultimately limited its longevity or ensured its success within a niche market. On one hand, its specialization meant that as computing needs evolved, systems that offered multitasking and advanced graphics eventually overshadowed the PCW10. But on the other hand, its simplicity and reliability cemented it as a beloved tool among those whose primary needs remained centered on text and document management. In direct comparisons, the fundamental choice of building an integrated, self-contained word processing system proves to be a double-edged sword. The very nexus of CPM, the Z80 processor, and the clever integration of peripherals like the built-in printer created a solution that was both cost-effective and easy to use, qualities that many business users found invaluable. However, as the computing landscape moved towards more generalized platforms, the once specialized PCW10 became a historical artifact, celebrated for its singular focus and its role in the gradual evolution towards integrated personal computing. In wrapping up today's deep dive into the Amstrad PCW10, we've journeyed through a wealth of technical details and historical insights. We've seen how the PCW10's modest 4 MHz Z80 processor, efficient usage of 64 kilobytes of RAM, and integration with CPM 2.2 weren't just arbitrary choices, they were strategic decisions aimed at maximizing performance for word processing tasks. Its built-in word processor and dedicated printer interface set it apart from more generalized systems, reinforcing its reputation as an ideally tuned machine for businesses and educational markets. Our comparisons with the contemporary systems have demonstrated both the advantages and the trade-offs inherent in the PCW10's design. Where the IBM PC might have been seen as a powerful but unwieldy for document creation, the PCW10 capitalized on its focused integration and ease of use. And while other CPM systems provided flexibility, they often lacked the refined user experience that stemmed from Amstrad's dedication to integrated design. The historical context of the PCW10 is as compelling as its technical specifications. In a time of rapid innovation, its design philosophy revealed a commitment to simplicity, reliability, and user-friendly operation, a philosophy that later influenced the development of more integrated computing solutions. From the countless magazine reviews to the technical service manuals and developer interviews, the PCW10 stands as a testament to an era in which computing was evolving from a niche hobby into a critical business tool. Whether you are a technical expert, marveled by the nuances of CPM's integration, or a casual retro computing fan who fondly recalls the tactile satisfaction of the PCW10's keyboard, its legacy remains significant. It's a reminder that even under the constraints of limited hardware, innovation can flourish, and that sometimes focusing on doing one thing exceptionally well can carve out its own enduring niche. Thanks for tuning into the Computer Vault podcast. If you enjoyed the show, please rate and review on whichever platform you're listening on. You can also check out my website at www.computervault.co.uk, where you'll find previous blog posts from the podcast episodes and details of my collection, which includes a variety of books, manuals, CD-ROMs, floppy disks, magazines, cassette tapes, and some old retro computers too, including the PCW10. Until next time, leaving you with a quote from Stuart Brand: once a new technology rolls over you, if you're not part of the steamroller, you're part of the road.